Yeah. Hey, everyone. My name is Bailey Hayes, and I will be here virtually with Dan Chiarlone. And our first question that we're going to try to answer throughout this talk is, what if you could write one application, run it anywhere, and on any cloud? And when I say that, what I mean is you can use any system architecture. We keep getting new CPUs. We have lots of different IoT devices. So how do we support that? And we want to be able to use different cloud providers, different services, and use different capabilities when we're running in local versus development and in production. And so what I really mean is literally anywhere. And you might be thinking, what about containers? Well, this talk isn't about comparing Wasm to containers, and I just want to plug, Docker loves Wasm. Wasm can run in a container. It can run, Wasm runtimes can run from Docker. You can run it in Kubernetes using the containerd Wazzy shim. So if you're into that, I recommend checking it out. But really, what I want to talk about is cracking open this container and looking at how we create apps today. So inside a container, it's really about virtualizing Linux, right? I bring in something that has lots of system libraries, lots of operating systems. Maybe it has multiple processes, maybe even multiple applications running. And a container itself is dependent on the architecture. So if I want to be able to run an image on many different CPU architectures, I build it for ARM, and I build it for x86, and everywhere else that I want to run it. But that's not even the level I want to talk about. Let's go even deeper. Looking at an application, and say your normal application wants to write to a key value store. Well, a normal key value store might be DynamoDB. And so to do that, I would typically import the AWS SDK. And so I'd have a typical import just like this. Now, if I was doing this with messaging, it's kind of the same thing. This example is using Kafka. Maybe if I'm using some of these libraries, I also have them as system dependencies, like maybe the driver is installed somewhere in my container. And this is basically how most of us write applications today. But there are problems. First of all of that I just showed you, that's not my application code. That has nothing to do with the thing that I'm trying to write or deploy. No, there was no business logic there. And that's somebody else's code. So if you're concerned about supply chain security attacks, if you want to be able to patch any types of bug fixes, I'm basically, as a normal app developer, patching my dependencies and churning and rebuilding my entire app and redeploying. But what if we did something different? And what if our app's logic was compiled into a WebAssembly component? WebAssembly components are portable across system architectures. And if I'm able to consume high-level interfaces, then perhaps I could start using standardized interfaces to be able to work across different services. And that means that our answer, and of course, no surprise to the question of how do you write one application that you run anywhere across clouds, is what we're proposing is wasi-cloud. Wasi-cloud is a new W3C WASI proposal. It's very early on, but it includes a lot of the things that I would need to be able to write a cloud-native application. And really, it came from this really awesome crew that I have up, and a lot of the initial APIs were introduced from Spider Lightning in a Cloud Native Rejects talk about a year ago. I included the QR code here, and I totally recommend checking it out. That was by Dan and Joe. Dan, my co-speaker here today. Now, the basics of it, and this is not actually the standard WASI key value proposal, but it's simplified so you can kind of understand. With WIT interfaces, it's basically, think of it as shapes that have to fit together. And one end of the shape is an import, and the other end is an export. And I have many different APIs, so many different shapes that I want to fit together. And when I build a Wasm component, I want to be able to fit it in on a host. And so a host will provide different types of interfaces that I can use. And one example of that is being able to connect, say, over key value with Redis. And so what does this look like? Let's see it in action. I'm going to be interplaying with past Dan here.
All right. We've told you a lot of things already, but at this point I feel like you're probably wondering, what does this all actually look like, right? I want to see some code. And to show you that, we've got a repository that contains an example implementation of a host for the WASI messaging proposal. and a guest that makes use of that host. So quickly bringing up the repo. All right, so first things first, let's take a look at the proposal itself. That should be under the wit folder. And in here you'll see that we have a bunch of files, but the general gist is that we have a messaging world that imports a producer, imports a consumer, and exports a handler. I won't show you all of these unique interfaces for the sake of time, but we can take a sneak peek at the producer one. Now, here, if you've used any sort of messaging service, you can see that we have probably the most basic feature that you would expect off of a messaging publisher, which is, well, a publish function. And you can expect the same for consumers and handlers and yada yada yada, you name it. Cool. So with that, we can actually take a look at the host. Now the main idea here is that we'll be creating implementations for whatever we're importing off of the messaging world. So, and you didn't see what the types file contained, but you can see that for that we're implementing an open broker, a drop broker, a drop error, a trace. But for the producer that you did see, you can see that we're implementing this publish function. And of course, these are all really just empty implementations, right? You can see that publish, all it's doing is really calling just a print line saying call publish and just returning an empty OK. All right. So with all this quote unquote implemented, we can have a guest that makes use of it. And we can see an example of that right here in the guest. Now the guest, well, the host implemented everything that we imported in the messaging world. The guest implements whatever we exported, which in this case was our handler that contains an onReceive function. So whenever the guest receives a message, it knows how to deal with it, and it will perform whatever business logic you have. Which in our case is calling open broker, publishing a message after doing some fake processing of the data with this function called fizzbuzz. All right, so we have a guest, we have a host. How do we run this? And to run it, I have this convenience make file, which will run make build. So that will actually give us our Wasm module. And this is just using whatever the language choice that you're using uses to build and target Wasm32 Wazzy. Here we're using Rust, so we just do a cargo build, right? And we target whatever we want to target. Next up, we'll componentize. In here, we get this Wasm module, and we'll turn it into a component. There's a little bit more here with adapts, but we won't get into that right now. And to finish off, you can then just run. And this run is running the host. Because the host, outside of him having those implementations that I showed you, it also contains a main function. And this main function will, set up your Wasm context, but meat and potatoes, it will actually just call Wasm time, passing in your guest component Wasm. And finishes off by calling onReceive on our guest. All right, let's do a make build, and actually this is an action. So building, this shouldn't take too long. All right, 3 seconds. We can now go componentize, which should be instant. We have our component. And next up, we can do a make run. So running, and hopefully shortly, we should have some messages popping up. Cool. So we saw the host. It made a direct call to our onReceive. And you see that the guest received the message with some data, right? Next up, the guest called the open broker, which we saw, and then it publishes. And it's publishing, you can see, with different data. So you see that our processing is, well, in fact, happening. And you see our call publish, right? This is from actually implementation in our host, and then the onReceive just concludes because that's what we had in the host, I believe. Call on receive. All right, and that's the general gist and how a host can implement functions, or whatever you have in a WIT, and a guest can make use of those implementations. Now, of course, this is sort of a fake host and fake implementations, right? But there are real hosts out there. This is something that's being actively worked on. In fact, Bailey here works on WasmCloud, while on our side we work on Spider Lightning's host called Slight. All right.
OK, thank you, Past Dan. All right, now we're all engineers here, so what we're proposing is being able to run anywhere on any cloud. And the first question most engineers are going to ask, OK, really, is it possible, and what do I lose? So some trade-offs. When we say that we're creating a common API and a common API standard for services, a different way of saying that is that we're targeting a common denominator, the lowest denominator. So as you move from this line from portability to richness, you lose a little bit of richness. So if you have an API to make something a lot faster or more specific to your use case, no problem. Go ahead and write your own WIT interface. That's totally OK if portability is not your goal. If portability is your goal and you have something that you would like to help us change, W3C standards are open. Please join us and help contribute. Next up, though, is I just feel obligated as a host implementer that while the Wazzy gives us basically a capability model in that we basically get function handles and know at a very granular level what types of capabilities we're letting guest modules run. It's on us to provide that sandboxing. And so within wasmCloud, for example, if I give them access to HTTP, I want to make sure that they don't have access to my Kubernetes API. These are all things that we've all learned before. That still applies. And the last trade-off here is that this is a new application paradigm. So initially, I fully expect a lot of people to start writing and targeting greenfield code, but I would love it in the future if we had some really great ways to automate this. But I imagine this is probably the first types of applications that we'll see. We've been spending the last decade figuring out how to containerize applications, and I expect us to start figuring out new ways to componentize them.
Now, wasn't Wazzy supposed to be like POSIX? Right? I mean, we're showing you all these high-level capabilities, like messaging one that you saw just now, but also key value, distributed locking, runtime config, SQL, HTTP, you name it. And that's a great question, which we're not really going to answer, and we're going to defer to then go install, which already happened, but you'll probably catch it on YouTube or whatever this is posted. But as you can see in the highlighted bit, we're going beyond POSIX, right? And it says that wasi-HTTP and wasi-cloud are two families of other proposals in development that show how Wazzy is about more than just POSIX APIs. So there you go. Go listen to Dan's talk if you're interested. Really recommend it. So a reasonable question at this point is, okay, we're going beyond POSIX, but how beyond POSIX are we going? And the answer to that right now is we're going as far as wasi-cloud core, which in itself is a world like the messaging one that you just saw, but it unions worlds. So you see, it does include Wazzy messaging, but it also brings in the Wazzy SQL world, blob store, key value, runtime config, distributed lock service, outgoing HTTP, incoming HTTP, you name it. Right? It unions all those things together to create this umbrella of wasi-cloud core. But something I also want to highlight in this slide is that this work is all fairly recent. You can see this comment was just from last week. So this is all very ongoing work, and there's no better time to get involved than right now if you want this to be different, or if you want this to go even further and extend POSIX even beyond what we currently have right here.
So far, we've shown running things locally. This next demo is going to be by Dan showing how to run this in Azure.
All right, so here we've got a Slide or spider lightning app that makes use of two capabilities. The first one is a key value at version 033, and messaging also at version 033. These specific capabilities have implementers, and in this case we can see them in their slide file. So you can see key values using AZ blob, and messaging is using nats. Now let's actually see what our app does. In here, first thing we do is we open connections to our messaging as both a pub and a sub, and also our key value through the name myContainer. Now outside our main loop, we subscribe to a topic with our sub called ping. And then we have a loop which will just continuously receive from that topic. So just continuously receiving there, and if the message is not empty, that means we've received something, which could be a specific command. Our app understands two commands. First one is ping, second one is reset. If we receive a ping, first thing that it will do is it will try to get from our key value store the value increment. If that value was already accessed, that means that it does have a value, and we will get an OK with its current value. That being the case, we'll just increment it, so if it's 1, it becomes 2. But if we get an error, that means that value has never been accessed, so we'll just increment and we'll set that to 1, and we'll return 1. With that, the way that our application returns a value is by publishing to a topic called pong with our publisher whatever we got off that increment. So it will be pong and the number of times that we've pinged. So first time will be 1, second time 2, yada yada yada. And the second app, or not app, command that we understand is reset, where it will just set the increment to be 0, and pong will be 0. All right, now let's just build this. Shouldn't take too long. I built it quite recently. And all right, next up we can do run. Now our app, our main loop already started. It's just continuously listening. And in here we can do a nats sub to the topic pong, which is how we'll see, return messages. On this side now, let's actually communicate with our app. So we'll pub a message to ping. Let's pub to ping, and we'll pub a ping. All right, there we go. You see pong times 2, so that means I had already pinged once. Let's clear that up. Let's do a nats pub to ping, and we'll pub a reset. There we go. We're now at pong 0. If we do another ping, pong 1, another ping, pong 2, another ping, pong 3. And that's the main app working. It's use of two capabilities 33. These a slide.
Okay, so far fairly simple, right? We've mostly been interacting with Wazzy messaging, and then in that last demo we added Wazzy key value. Now, I want to show you a technique that I think a lot of people are going to start using. My team has been calling them Wazzy Fills because it's sort of like it's using the adapter pattern, and it's taking a component, looking at its interfaces, and then making it work within our ecosystem, within the ecosystem that I work in, which is wasmCloud. So if I have a component, and in wasmCloud we call those basically actors, I'm able to slot that inside wasmCloud. And remember, all of these interfaces are basically shapes that I need to be able to plug together with imports and exports. In the demo that I'm about to show, it's a little bit different in that even my capability providers are distributed, and so I call them over what we call a Wasm bus RPC call. And I do the exact same thing with the same code as Dan in a completely different stack. So let's pull up some code. Now, given time, I'm going to do a little bit of a cooking show here. So first, let's look at our source here. As you recognize, there's nothing in here about wasmCloud or Slite or any other application framework or SDK. And my logic is the same as Dan's. I get a ping, I increment my KV bucket, I get a reset, I'll reset it. So once I build that, and you can check out the code, or I can run this live for you after the talk, but I've already built it. I did the exact same adaptation that Dan showed earlier that converts it from Wazzy Preview 1 to Preview 2, which makes it basically a component. And if we want to actually look at what that is, I can, well, I'll just show you. Here it is. This is what that wit syntax looks like once I've produced that component. I have essentially something that requires messaging, uses WASI messaging, and it also needs key value. The rest of this stuff is actually just really saying I need WASI preview 2. Now, let's deploy this thing. I'm going to use an application created by Peter Hune. I think it's probably the easiest and best way to get started with components because it gives you basically visual metaphors for how to do all of this. I've created a Wazzy Fill for messaging that'll make it work within the wasmCloud host. So I'm going to add that. That's what that one looks like. I'm going to add another Wazzy Fill for key value. Now, let's add ping pong. Ping pong is that component that I built that has our application business logic. That's the same as Dan's. And one more. This is to work within wasmCloud. So, like I said before, wasmCloud expects everything to act like an actor. And the way to do that is to export an interface so that the host has something it can call, so that it knows that it acts like an actor. And so I can drag and drop basically the interfaces that need to be bound. In this case, I added my messaging to the messaging import here. Same thing over here to key value. Now for handler, I attach handler to my actor wrapper. I'm also going to attach messaging to this one here. And last but not least, I check off saying this is the interface that I want to export. I'm going to download this component. I'm calling these linked components. And this is the thing that I just built. It's a component that combines all of these other pieces together. It implements, or really expects, the host interface. So this host is my wasmCloud host. And here, the actor is an actor that I kind of how I expect it to work within my ecosystem. So I've already downloaded and deployed this. Now, this is kind of the big trick, because networking's been interesting. I'm going to do the exact same thing, but I'm going to interact with Dan's application over NGS. NGS is for NATs. It kind of is globally distributed, so it makes it really easy for me to do demos like this, where I don't have to worry about DNS. So I'm using our same credentials. Now I'm listening, and I'm going to ping. And I expect to get some pongs back. Actually, let me swap internet. And so we're incrementing our little key value counter. And what this is Dan's. Going through my system back to Dan's. So it's not the most exciting, I know. But let me show you the cool part, the crazy part. Right, I actually was running this on localhost. This is a Mac ARM CPU architecture. This is a little ping pong. Ping pong's running here. I also have my WASI messaging provider. That's kind of that thing that's sending it back out. And when I look at where this app is hosted in Cosmonic, I can jump over and see, oh, but I've actually also deployed this actor over in GCP, and I've added x86 Linux to it, so we've got another CPU architecture. And so my stack is pretty different from Dan's. So I've just combined two totally different stacks. Dan's is running in AKS and Kubernetes. Mine's doing something with wasmCloud, which is a little bit of Nomad, a little bit of AWS. I myself distributed it so that I'm running against GCP and on my local Mac. And to me, that's just kind of amazing that I'm able to wire together all of these different capabilities. And I could have used any different messaging provider. We use NATs because it made this part of the demo a lot easier. And so that is how I can say Slight and wasmCloud can work together. And you can imagine that with anybody else that's using these standard APIs. So that's one application, runnable anywhere on any architecture, platform, or cloud. And that's pretty huge.
So what's next? And, well, the good news is the future is bright. You know, the work with components is just beginning. As you can see, we have contributions happening just last week, pretty meaningful contributions that we're presenting on just now. So the future's bright, but we are at a point where we want more contributions. So if you'd like to bring your input, we recommend that you look at issues on GitHub, on Wazzy. Maybe the specific issue would be a good one that lists all the proposals that we didn't get a chance to show about wasi-cloud core, like you saw a bit of key value messaging, but also HTTP, type of thing, distributed log service, SQL, blob store, and so on. And if contributing to the interfaces is not your thing, you can also contribute to capability providers. So bring on your own implementer to Spider-Lightning or wasmCloud, or even one that we didn't show today, like Spin from Fermion. Yeah, so if you just want to get started, start playing with the tech, here are some resources to get started with Spider-Lightning and Slide, and also wasmCloud. Thank you so much for listening, and I'll see you next time.
OK, so I guess I'll just reiterate one more time, because I'm not sure it's sunk in. We just saw components running for realsies in many different clouds across different architectures, and it wasn't easy to make this. I do think I have to add that one last caveat. This is super early, and we had to do a lot of different things to make it work, but we did it, and it's end-to-end, and it is real, and you can pull our code and run it. If you pull it next week, things might have changed, so you might want to do it right now, but it's pretty exciting, and I hope you can tell how pumped I am. And this work it wasn't just me and Dan, it was a ton of different folks across the Bytecode Alliance. I showed off a lot of different tools and capabilities. We were using Wasm Time, we were using a bunch of stuff in Wasm Tools, and the component model itself is a new ABI, and it's a big lift to be able to change ABIs. But the types of capabilities that it gives you, being able to do something like this is going to be really amazing, and I think it's going to change the way that we write applications today. Questions? Hey, Ralph.
I always ask the same question. What was the absolute worst part of that for you?
Wow, yeah, networking turns out to be the bane of any demoer's existence, yeah. So trying to go across clouds is hard. You can use some tools like NATS and NGS to do it. But when you're using a bunch of new things, you just always trust that you messed up and you used the wrong code or something. But it's always networking. That's always the problem. So I would have saved a lot of time if I just trusted myself and trusted all the code that other people had produced and checked networking first. But I would say it's new, and once I started using Wasm Builder, I think if anybody else is getting started, I had tied together basically my dependencies incorrectly between imports and exports, and by doing that, it wasn't obvious what was wrong until I really looked at the what, but if I had looked at it in the Wasm Builder app, it would have been just immediately obvious. Any other questions? Cool. I'm off the hook. All right, thank you.